All right, we're going to take a quick look at naming binary molecular compounds. A couple rules just to think about here. The nice thing with these is you don't have to do predicting, right? You don't have to look at ion charges and go, oh, there's got to be 3 of those and 2 of those so that the ions are balanced or anything like that. Here, the name itself will tell you with prefixes, or the formula will tell you with the numbers, how many of each atom there is. The rules for naming these guys are as follows. Number 1, always name the first element as the element name. That was fun. Come on. Also, learn how to spell the word name. Number 2, only use a prefix with the first element if there is more than one. And number 3, the second element's name will end, computers are great, will end with "ide", just like the ionic. So sulfur becomes sulfide, chlorine becomes chloride, and so on. And number 4, the second element's name will always have a prefix. All right, so as shown on this page here, this is in your workbook 2, page C32, mono is 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa, hepta for 7, octa for 8, nona for 9, deca for 10. Most people are pretty familiar with the stop sign being an octagon, and so that one's not too bad. You do need to memorize these. Hexagon, again, for 6, usually not too bad. Triangle, 3. This is annoying for 2 is di, but most people are pretty familiar with this element. Carbon dioxide. Okay. This kind of illustrates most of these rules here. Always name the first element as the element name. Carbon. There it is. It's not carbide or anything like that. It's just carbon. And only use a prefix with the first element if there's more than one. There's only one carbon, so I don't need to say monocarbon. So carbon, then there's 2 oxygens, so it's going to become dioxide. It ends in ide. What if I have this one here? CO. I've got carbon, and I have oxygen, so it's going to be some kind of carbon oxide. But, second element's name will always have a prefix. This is one of those goofy ones. They don't like us to write this as carbon monoxide, because that looks like monoxide or something weird like that. So this is just going to be monoxide. Where we get to use prefixes with the first one, again, is if there is more than one of them. So if I look down this list here, questions 1 through 16, I can't see 16 the way that it's set up on my screen anyways. But if we look at those there, only 10 and 11 have more than one of that first element, and 3, sorry. So those would be the only ones there that I'd need to use a prefix with the first one. So just to kind of look at that, so I've got N2O3. I have 2 nitrogens, so I have to use a prefix. So this becomes a dinitrogen. Oops, nitrogen. And then I've got 3 oxygens, so this becomes trioxide. Okay. Most people have less trouble with this one. Now, that being said, there are a few that you have to remember. Okay. So first of all, if you look back on your periodic table, we'll get there. We have this nice little chart that they give you of polyatomic elements. And what this tells us is that we have a few that are always going to be, as an element, we would find bromine as Br2. We never find one bromine atom just hanging out by itself. It's always 2. So it is actually a polyatomic or a binary compound, but it's got 2 atoms. So this would be, we would call this bromine. Normally at room temperature it is a liquid. That's why it's got this dark background. Same as mercury at room temperature is a liquid. That's why they have that there. Anyways, bromine though is Br2 always. In fact, everything in this column is going to be whatever and 2. So you look, acetine, At2, iodine, I2, Br2, Cl2, F2, and hydrogen, which normally we don't see on this side here, but it would also be H2 as well. Normally, the way I will teach people to remember these is hydrogen hides off in the corner by itself on the other side of your periodic table. And then I have 7 more in the shape of a 7. Let me draw that out for you with the fun green color. Starting at number 7. I don't know if you can see here, this is sort of like the shape of a 7. Starting at number 7 plus hydrogen. And then we've got phosphorus and sulfur, which are oddballs as well. You got to just remember this is P4 and S8. Anyways, those are some of the oddballs. And then there's a couple more. So some of these you'll recognize from, for example, biology. One of those from biology you should be able to recognize is C6H12O6. That's glucose. So there is actually a naming system for this in terms of all kinds of different sugars. You don't have to worry about that for Science 10. Another couple non-standard ones actually show up right on this page here. Number 8, CH4. Using the rules up here, this would be carbon trihydride. The common name for this guy, though, is methane. You might have seen that in the past as well. Then we've also got NH3. Is another one you should know. That one shows up somewhere. Here's one, number 13. And that is going to be, again, looking at our naming system here, this would be nitrogen trihydride. And the common name for this that you need to know is ammonia. Whoops, slow down. Ammonia. There we go. All right, another 2 that you need to know, O3. So I said oxygen is normally O2. That's the stuff we breathe. O3, I am positive you've heard of this as well. This is ozone. And then the last one, I write it down. Really tough one, H2O. This is water. I'm sure you've heard of this one as well. This is number 15 on your list here. Common name here is water. I suppose we could call this dihydrogen monoxide. Normally, just water is good. Thanks.